Okay, welcome to section 8.2, which talks about area. So 8.1 was about distance. Now we're talking about area, which is kind of like, you can think of area as having two dimensions, right? So we use area all the time. Let's say like how much paint will cover one of my walls. I need to know the area of my wall so I can figure out how much paint to put on there, just various things. There, homes, fences, what have you. And so these are some of the common figures and their corresponding area formulas, okay? So for a square, since area for it's base times height, but because the square, the sides are the same, the formula for area of a square can be considered just one side times itself, which is side squared. Now for a rectangle, we call this length and width, but it's analogous to saying base times height in a parallelogram. So we just multiply it because that creates all the space inside the area. Okay, so let's say for instance, one way you can think of it is if I have a strip of length L, and I want to multiply it W times, eventually I'll fill up this whole section right here, and that's considered the area. So the area of a rectangle, you can think of it as length times width. Parallelogram, similar story, because it's basically, if I was to take this little triangle, cut it out, and then put it over here, okay, I would get, so I put this little triangle. The whole part would still be base, and the height would be a height, but it's now a rectangle. So, length times width, base times height. Okay, so for a parallelogram, so remember that a parallelogram, these two sides are parallel; they never intersect, and neither do these guys. And the opposites are congruent, right? Okay, and a rectangle is just a special parallelogram, and so is a square, by that matter. Okay, so that's that, and then an area for a triangle is 1/2 base times height, and and we can talk a little bit about why. In that it's basically, you can express any triangle as a rectangle or a parallelogram. That's one way to think of it about this, but it's 1/2 of it. So that's kind of like the hand-wavy explanation of the proof of why a triangle's formula for area is 1/2 base times height, but that's what it is. And then a circle is the one that I was trying to show you before. Area is equal to pi r squared, where if I was to cut the circle into all these little sections, I'd eventually get a parallelogram where you have a radius here, and then the circumference is going to be spread apart these two, top and bottom. So it would be pi r here and then pi r here, right? Because remember, circumference is 2 pi r. And then it's a parallelogram, basically. If I express this circle as a parallelogram, then the area for that would be pi r, so base pi r times the height, which would be r, so pi r squared. Okay, so these are just some common formulas that you need to be familiar with. Essentially, the top three are all the same, except that because a rectangle, sometimes we usually call it, you'll hear it as length and width, so that's why we use LW. And for square, since length and width are equal, we just call it side and then multiply by itself, which gives us side squared. Okie dokie, that's that, guys. Okay, so let's go ahead and start using these. So the parallelogram below has a base of 5 centimeters and a height of 2 centimeters. So let's find the area. So the base is 5 and the height is 2, and then all we need to do is just plug it into here. So area is equal to 5 times 2, and this is going to be 10 centimeters squared. Okay, why is it squared? Because this is a two-dimensional object now that we're talking about. We're talking about an area. It's no longer a distance. If it's just one single line, then it would be one-dimensional centimeters. But because it's two-dimensional, we write centimeters squared. Yep. Okay, so let's do another one. triangle below has a base of 6 and a height of 3. Find the area. So what is the area for a triangle? 1/2 base times height. Okay, so base is 6 here, height is 3, and then we just plug it in. So the area will be 1/2 times 6 times 3, which is just going to be half of 6 is 3. 3 times 3 is 9. This is 9 centimeters squared. Okay. And then now here, there's no picture, but it says find the area of a square with side 35 millimeters. So it's just going to be a square, and every side is going to be 35, right? Because the square, all the sides are congruent, right? But what's the area of a square? That's just going to be side times side, or side squared. So that's just going to be 35 squared, which, let's go ahead. I'm good at mental math, but let's just double check. So 35 times 35 will give me 1,225 millimeters squared. Okay, so now it says find the area of a circle with radius 14.5. So what's the formula for area of a circle? Okay, remember it's pi r squared. So we have that the radius is 14.5, and that's really all we need because we know that pi is a constant. Okay, so it says round to the nearest whole number. So if I was to take my calculator, let me get a better calculator here, it would be pi, so pi times 14.5, and I need to square that. So see the little x squared key? I'm just going to hit that and see how it gives me that little 2. That's squaring it. And then that's going to be 660.5, but it wants us to round to the nearest whole number. So to round to the nearest whole number, we look at immediately to the place value to the right. So 5 and up, we move up, we round up. So this is going to be 661 millimeters squared. Okay. All right. What if we have something like this? Find the area of the shaded portion of this figure. Well, one of the nice ways to think about it. So this is given that this is a square. Okay. So here we're given a circle with a diameter of 12, which means that it has a radius of 6, and a square that has a side of 12, because of course the radius is equidistant everywhere. So if this is 12, that means that this is also 12. Okay. Which means basically that this right here is 12. Okay. So how do we find the shaded portion, just the outside? Well, if we find the area of the square and we subtract the area of the circle away from it, we subtract that, we will find the area of, all these little tiny weird pieces, okay, of the square that's not circle. Okay, so that's kind of the idea. So the area of the square minus the area of the circle will give us the area of that weird thing. Okay, so that's going to be, the side is 12, but also the diameter is 12. Okay, so the diameter is 12, which implies that the radius, since it's half that, is 6. Okay, so what's the area of a square? Remember that that's side squared, and the area of a circle, the formula is pi r squared. Okie dokie. So side squared is going to be 12 squared minus, and then the area of the circle is pi r squared, so that's going to be pi times the radius is 6 squared. Okay, and that's exactly what we want to figure out. So that's going to be 144 minus 6 times 6 is 36, so minus 36 pi. Okay, so let's go ahead and calculate that. So we have 144 minus 36 second pi, and that's about, the area of this weird part, the shaded portion part, is going to be 30.9 feet squared. Okay. All right, and that is it for area. Your super fun homework is section 8.2, 1 through 19 on. Good luck, happy studying, and I will see you on the next video.